we would like to find the real and imaginary parts of the function w equals f of z equals e to the z bar. So z, the complex variable, is x plus iy, where x and y are real numbers. And so therefore z bar is x minus iy, the complex conjugate. So e to the z bar, which is our f of z here, is equal to e to the x minus iy. And from the definition of the complex exponential function, this is e to the x, the real part, times cis, imaginary part. The imaginary part is minus y. So e to the x minus iy is e to the real part times cis of the imaginary part. E to the x, cis minus y, where this cis means cosine of the angle, whatever is in the parentheses, plus I times sine of the angle. So in this case, our angle is negative y. So this is e to the x times cosine of negative y plus I times the sine of negative y. And then using the evenness of the cosine function, the cosine of negative y is the same as the cosine of y. And using the oddness of the sine function, the sine of negative y is the negative of the sine of y. So we can take the negatives out of the sine and the cosine. Cosine of negative y is cosine y, and sine of negative y is negative sine y. So this is e to the x. If we want to split the real and imaginary parts up, we distribute the e to the x cosine y. There's the real part. And then minus I e to the x sine y. So there's the imaginary part. So the real part of e to the z bar is e to the x cosine y, and the imaginary part of the function f of z equals e to the z bar is negative e to the x sine y. Notice that we don't include the I in the imaginary part. The imaginary part is real.